This presentation is called MySQL Active Security Honeypot, which was also known as Atomic Honeypot. So I'm Alex. I am a principal security engineer at AWS. I'm currently leading relational security red team. We are doing offensive security. We're doing open source database security research, and our goal is to find as many security issues as possible before a real bad actor will find them. And originally I was at MySQL AB since 2006, acquired by Sun Microsystems, Oracle, Percona. And this picture, this is actually my t-shirt. I can show you. This is my t-shirt that I am wearing right now. So MySQL, I saw MySQL 5.6 was the end of evolution. And now MySQL 8.0, which didn't even exist, well, it was existing, but it was not really used at that point, is now end of life. So this is our agenda for today. And I put this GitHub repository early on. So this is what we have contributed. We have created MySQL Active Security Honeypot, and I will walk you through of what our reasoning was, what exactly we have been doing, and at the end I will give a quick demo of the honeypot itself. So this is our formal agenda for today. We'll talk about high interaction MySQL honeypot first. Then basically we created a high interaction MySQL honeypot and we converted it to atomic, going atomic. How we did that, right? So we found this vector, attack vector, which I called MySQL Server Can Attack You. And we have been finding CVEs in MySQL. We have found at least 3 CVEs in MySQL which we have reported. We are presenting, I will be presenting one of the latest one today. And then at the end, again, Active Security Honeypot, Atomic Honeypot, this was basically our goal, right? MySQL Honeypot strikes back. Whoever tries to connect to that honeypot will try to pretty much hack back them. So that was the idea. So let's start. Basic information. Bots are everywhere. They are scanning your servers and they do it very fast, especially on a well-known ports. And obviously, a database servers are a big target. If you expose your database, someone will come and try to connect and try to brute force the passwords. So this is exactly what is happening here. The MySQL server is open from the internet. So we were thinking, what if we will replace that MySQL server here with a fake MySQL server with a honeypot server? So now we started with this thinking, and other people have been doing that. What if we will just start a TCP server? That works for Postgres, but it doesn't work for MySQL. Because MySQL protocol is server initiated. If you will just start a TCP server, someone will try to connect to that, but MySQL client will not be able to connect without the prompt. So if you start a normal MySQL server and do the telnet TCP connection, you will see this. This is exactly what is needed for the MySQL protocol to succeed. It needs the version number, it needs the salt, and it needs the plugin name. So just listen on a port is not enough. We need a real database. So when we are thinking is how we do the real database, we came up with different ideas. And the easiest idea at that point was to use the Python library. So Python have a library called MySQL Mimic. It's pretty powerful and it's very easy to use. So we created a fake MySQL server based on that MySQL Mimic. It supports a lot of things. You can also configure it and override the standard behavior, which was very useful for our use case. Also support TLS, SSL, and other stuff. So now we are simulating MySQL protocol with a Python script. Then we run this standard honeypot on an open MySQL internet server, right? And then we immediately see someone is trying to connect. So the bots are connecting to your server. And what we are seeing, and this is where we started, right? We're seeing connection attributes. So MySQL support these connection attributes, and you can see immediately the platform, the client version, operating system, client name. So this is how MySQL defined those attributes. So just starting a high interaction MySQL honeypot will give you some information. So those are the real interaction with the real attackers, with the real bots, right? We are collecting that, and then there are lots of useful info, and we will use that later on. So now from there, we started this high interaction MySQL honeypot, and we determined that there are two major attacks going on. Attack number one is an attempt to own MySQL server and create a backdoor. This is pretty old, but what we and it doesn't really work. It only works with a server from 2013. But what is interesting is by you looking at those attributes, we already know that they are coming from, they're running on Windows, whatever code they are running on Windows using really old client version. Now the second attack was much more interesting. This is ransomware attack. So ransomware attack is very common right now. And what it does is it connects to your database, it downloads and deletes the data, and it asks for ransom. So basically what we have been seeing from the customers, from the victims, right, is their databases disappeared, and instead of that, they will see the single table called README with ransomware instructions. And then here, again, we see the attributes, Linux, we know the client name, libmariadb, we know the platform, and then we also see the program name. We see this MySQL dump here, so we are guessing that this is what they're using to download your database. So now, from the first implementation, we have collected some information about the ransomware attack. And then from there, we wanted to create a prototype of atomic honeypot. What we wanted to do is we're mostly interested in how they do this. How does this ransomware bots or ransomware attacks are happening, what they're using, what's their source code. And this was our goal when we have created the atomic honeypot. We want to interact with attackers, we want to download their evil source code. So the question is how we can do this. Now, we have been doing a lot of database security research, specifically MySQL security research. And we have been juggling with the different CVEs. The one on top is really old, MySQL client arbitrary file read. But then 2023 CVE and 2024 CVE is the ones that we have found and filed. Let me start with the beginning. What this is a vector an attack vector where MySQL server attacks MySQL client. Basically, you connect to a rogue server, and then a server will actually execute a code or do something else, for example, read a file from your client. So imagine that for a second. Your database has been hacked. Now, you are connecting to the database, you want to restore it. You establish the connection from your laptop to the database that you think is your database, but it's now belonged to a bad actor. And now your computer, your laptop is hacked. That bad actor executes the code on your computer. So this is exactly what here, which is the CVE 2023, and we found it in 2023. We found this vector in 2023, and we presented at the HITB conference, security conference, and we presented exactly this vector. And I will talk about that today, and I will explain how it's possible. So now, let's start with an even older CVE, the CVE that made that happening. So this is MySQL Client Remote Code Execution, RCE, from 2019. Now, exactly how it works is this again, right? I'm repeating this information, right? You are MySQL DB, you connect to a MySQL server, and then your laptop, your computer is being hacked. How is this even possible? So to explain that, I need to explain a little bit of MySQL protocol. So this is MySQL authentication part oversimplified. On one side, we have MySQL client, and MySQL client is connecting to the MySQL server. And then remember, MySQL server is presenting itself by telling it the version, the salt, and the authentication plugin. So now, in this particular case, MySQL client says, hello, MySQL server, I want authentication. And I have a username and password, the hash of the password. And by the way, I want to use MySQL native password plugin. So MySQL has the plugin infrastructure, and you can write your own plugin. In this case, MySQL server says, very good, I loaded this MySQL native password plugin, and I checked the hash of the password using that plugin. Access granted. But now, let's say there's another situation. MySQL client will go and say, hello, MySQL server, authentication, please. And by the way, I want to use whatever plugin. And here, whatever plugin is the name of the plugin. And MySQL server said, I don't know what this, whatever plugin. Let's try another plugin. Again, this is the names of the plugin. And MySQL client will say, okay, sure, I will try to load another plugin if I have it. So let's look at the code. This is the source code of the client library. It's actually very old code. It's 8018. Remember my t-shirt? It's not even there. 8018. So what this code is doing, again, this is not a server code, this is client code. What this code is doing is it takes the plugin name that comes from the server, and then it appends the SO extension, and then it will try to build a string based on the plugin dir, which cannot be set from the server. It's dedicated directory for the plugins. You cannot change it from the server, right? But it's trying to build that string, and then finally it will do deal open, which is load library. It will load the library from disk. So the plugin name will become the path for the deal open. So now Now, I will not join it. Sorry, guys. Will not join that. All right. So now, what if we will pass this as a string to what if we'll pass that as a string to the plugin, to the client, right? So this is a directory traversal. And because we have a directory traversal, what will happen is that you will try to load this DL path with a // library SO. So then we can actually load an arbitrary file on your computer, on your client from the server. So this is the finding that has been found by, not by us in 2019, but we have decided to look at that and implement a proof of concept. Now, it has been fixed. It has been fixed, as you can see, a long time ago. 5.6, 5.7, 8.0, and all subsequent versions of MySQL have that fixed. So what it's doing is it is trying to determine if there are separators in the code. And then if there are separators in the plugin name, because plugin name will always just name, it doesn't need to have a separators in it, right? It will say no paths allowed for the shared library. Right? There's also a different implementation for MariaDB, but that doesn't matter. So this is a quick summary of the directory traversal. Only older versions of MariaDB and MySQL, but if you are using the versions that are currently on my t-shirt, then you need to upgrade. Again, this is not a server, this is client, right? So you need to upgrade the client versions. This is actually important, right? Because people think about the security, they think about the security of the server. They don't think about the security of the client. So you need to upgrade the client versions as well. So now, again, back to the proof of concept. This is a sort of prerequisite of the active security honeypot. We want to do exactly this. We want to create a rogue server which will somehow send back a plugin name, for example, to the bad actors who are trying to connect to your database. So what do we need for this proof of concept? We need a control of MySQL or MariaDB server. The version of the server doesn't matter. You basically replacing that server with a rogue server. Then I need a vulnerable old version of client library. And then we need an ability to push exploit code as a shared library. That's the most challenging part of that. So that sounds complicated, so let's try. So here's our goal, right? Our agenda. First, we write a rogue server with the ability to push a plugin name. Second, we will be loading an arbitrary file as shared library. And then we will try to push the exploit code to the database administrator machine. So we already have the rogue server, right, from the honeypot implementation. We already have that. And what we'll need to do is we'll need to change that a little bit. So we will push the plugin name to any request. So remember, authentication happens at the very beginning, obviously. So it doesn't matter what will happen after that. We just need to push the plugin name with our directory traversal injection at the beginning. So then this is exactly what we are doing. We have one parameter, well, two parameters. The first parameter is a plugin name, which will include our injection string, and then the port number. So now when we have that, the second thing is how we will deliver that payload. How do we load an arbitrary name as a shared library? Right? So the problem is how do we actually load the exploit code? we need to have a shared library with exploit inside the init. And actually, that is really easy to do. We're talking about SO file, right? A shared library on Linux or DLL on Windows. Every time you do for Linux, actually, for Windows it's more complicated, but on Linux, whenever the deal open call happens, then whatever inside of the init will be triggered. So what we're doing here, we are creating a file, and we are also opening a calculator just to confirm that we have a command execution. And it's very easy to just compile it, and then we have the bytes. So now it will be also interesting, it will be good to disguise that as an arbitrary file. Because remember, when a MySQL client will create a name, it will append .so on Linux or DLL on Windows. So we found this really old code in MySQL. This code is from 1984. And this code actually still exists in MySQL. There is no problem specifically with the code, and this code was written by Richard O'Keefe as a function, which is his name should be here in the Computer History Museum. He was a famous computer scientist. So the problem is not with the function, but how you use that function. So see this character here that has been allocated inside of the MySQL client code, and then it depends upon the length, 512 bytes. So because of the function is copying bytes into DL path, it will actually, if it will reach the 512 bytes, it will push out everything that is after that stream. There's no buffer overflow. It's a length overflow, right? So it will push it out. So because of that, we can actually calculate the plugin name precisely so that the name can be arbitrary, and SO will not be appended to the end of the plugin name. So we did that, and we tried to do this with just //AAA, right? And when we get this cannot be loaded, cannot open shared library, no such path. So then we updated the function, the Python function, to actually generate a flow, like a string, precisely to the 512 bytes. So we're using this backslash as a filler. On Linux, it doesn't matter how many slashes you have in the file name. So we created that function, and then it will generate the name of the plugin so that it will overflow that buffer. So now we have an ability to load an arbitrary file name as a shared library. So the final step is we need to somehow push that file to your laptop. That ended up to be the most challenging piece, actually. And we found a way to do some sort of, disguise, social engineering. So imagine that you will send me, I will send you my resume on LinkedIn. What would you do? You will probably save it on disk somewhere. You don't need to open it. You don't need to look at that. You don't need to execute it. This file just needs to be on your computer. And if you're on Mac, for example, right, I know it will be probably your username, documents, or downloads, and stuff like that. Yeah, 5 minutes. Yeah, there are lots of information in this slide. All right, so disguise as a resume, and we can actually do this easily. So we have created this proof of concept, and we are trying to open a calculator here. So my colleague Martin sent me a resume, and now I have this PDF file on my computer. On a bad actor side, they run this rogue server and then precisely calculated the name of the plugin. So now on that, I'm connecting to a rogue server to my hacked database using a very old version of MySQL Workbench. So now I'm just establishing the connection, nothing more than that. This is plugin, and then I'm just connecting to that, and let's see what happens. Calculator. So it also gives you an error, but the error doesn't matter because it has opened the calculator. That means that this your laptop has been compromised. All right, so I'll go quickly here. So the next thing that we found is actually the bypass of the fix. Remember, the 2019 issue has been fixed by both MySQL and MariaDB. And then we found a bypass. Bypass is check to set. So MySQL supports different check to sets, but the old code from 1984 doesn't know anything about the check to sets. So in different check to sets, it can actually use 2 bytes. The fix is looking for a slash, a separator. If you are sending something with a default check to set UTF-16, UTF-16 is 2 bytes only. It's 2 bytes always, despite of whatever the language is. So the code will skip over 2 bytes and another 2 bytes and another 2 bytes. So this is how you can disguise your slash in it. So we found that this is a bypass. And this is the screenshot of using a command line MySQL client and can actually execute the code. All right. I think, let me see how we can skip faster. Let me quickly go through this. So we found yet another issue on the MySQL dump now. And with a MySQL dump is a backup system, right? It will produce a logical backup. When you connect to a server, it will basically give you whatever the server will produce. Now, MySQL recommends you how you can copy data from one server to another server. You can use Linux pipe. You connect using MySQL dump to your local server, and then you pipe whatever you send over. 1 minute, I'm running, I don't know, maybe I can use 5 minutes of the break, if that's okay. All right, so you pipe the data back to MySQL command line, and you recreate the server. What we found is this. A MySQL dump is usually pretty good at escaping whatever they get from the server. Not in one case. This one case is displaying the MySQL version. So I'll give you this example. This is a simple patch, how you can actually convert a normal MySQL server to a rogue MySQL server. You need to put end of line in the version name. So then what will happen is you're connecting with the telnet, and then it will display the version number, end of line, and this touch command. So what happens is MySQL command line client support this meta commands. If it sees backslash and exclamation mark, it will treat that as a command, OS level command. So it will just do system on that. So if you create that server and then MySQL dump will connect to that server, it will produce that poisoned MySQL backup. And that MySQL backup will be fed to the MySQL command line, and then you will have the command execution. So we have created the MySQL Active Security Honeypot. This is a tool, we published it. Please take a look and feel free to use that. We have implemented 3 CVEs in it. So we have put the version stream payload that I just explained. We have put the plugin name, plugin dir there. So we have implemented 2 CVEs there, 3 CVEs actually. So this is the 3 recorded demos of what the honeypot can do. So let's start with the 2023 Rogue MySQL plugin. Yeah, really quick. So we are creating the shared library here. And we will try to basically execute the calculator. We are compiling the shared library and disguise it as PNG in TMP. So now this is our active security honeypot. We are running on this port using this plugin name parameter. And then we will be connecting to that honeypot using MySQL, really old MySQL command line client. And we are connecting to that honeypot, and let's see what happens. Here we go, calculator. So this is an implementation of 2023 Rogue MySQL plugin. The next one is the bypass, the character set bypass. I'll quickly run that. We have implemented that as well. Let me actually skip to the MySQL dump version stream. That's similar to this, but now we will be doing MySQL dump implementation. So we'll do the port, the version stream will just specify the payload. Specify the payload. We're connecting using a recent, more recent MySQL version. And doing a dump. Then we'll restore that dump. And try to import that dump. All right, now we have a calculator. So I think that's it. We have implemented the Atomic Honeypot, and PostgreSQL Honeypot is coming. Thank you very much.